2024, Hamburg, Germany. We're at the ISC 2024 Student Cluster Competition, and we're going to meet Team ETH Zurich. How y'all doing today? You okay?
Very good.
Yeah? So who are you?
Hi, my name is Benedict. I'm the team captain for...
Team captain? Come on. Yeah, it's a tough job.
Yeah, exactly. So I'm the team captain for the student cluster competition. And I myself was working on NEKO. Yeah, it's a scientific application for high order spectral element flow.
Everybody knows that.
Yeah.
Who hasn't? Who doesn't know that about
common
NEKO?
knowledge? Exactly.
You want to do some high element spectral flow, you're going to go to NEKO. You're not going anywhere else. Stop looking after you find NEKO. Good. How's that going?
Very good, to be honest. So we were very well prepared, so no big surprises. And the test cases they provided us with, which we should run here at ISC, were exactly what we prepared. So yeah, pretty smooth sailing. Also, generally, I think we're all very hyped for this student cluster competition because, yeah, we prepared a lot and it was very fun. At times also frustrating, but generally it's really nice to apply what we learned in theory from university in practice.
And by the way, that's going to help you out so much in job interviews where you can talk about real world problems, real world stuff. If you're just in the classroom, you can't. So good, good. Who's this guy next to you?
Yeah, hi, my name is Leonard. And I'm also working with Benedict on the NEKO application, the fluid dynamics application. And yeah, like Benedict said, it's going really fine, and we are just making small modifications. And yeah, that's it basically.
All good.
Yeah, it's good.
What kind of speed up we looking at?
Speed up.
You got a number?
Yeah, I think it's like maybe 20%. Should be 20% speed up. That's really good.
Are you happy with 20%?
I mean, for the hardware we have, it is really, really good.
I mean, are you satisfied?
Satisfied? Yes. Like I said, we make some small modifications and maybe we can get a little bit more. But it's good for now.
You think you're done?
Yeah.
Then, with 20%, with small modifications?
No, maybe we can get like up to 30%. With small modifications.
Okay, that's what I'm talking about.
Yeah.
I like that. What about 40?
Sorry?
What about 40%?
Oh yeah, will be tough. Will be tough. We don't know. Like,
but you're tough, right?
Yes.
You don't give up, right?
No, we don't.
It's not. I'm looking at my watch. It's nearly 1:30 on Tuesday.
Yes.
This competition's not over.
Yeah, I mean, we have like 4 hours left, 3.5, so we do our best.
Okay.
Yep.
Okay, good. Good. Are you motivated now?
Yes, definitely. Yeah, we are.
Okay, great. Let's go meet the next one. She's going to be really looking forward to this now, after what he just went through.
Hi.
So what's your deal?
I'm Julianne, and I'm working on the second application for like this competition, which was Conquest. So
what is Conquest?
It's about like calculating the position of electrons inside some material. So for like the input that we got a bit earlier was like in a water cell, calculating the positions of the atoms. And yeah, we just like made our benchmark run, so we're really happy with the results we got. And for now, we're letting
you want to go down that road of we're happy with the results we got?
At least for now. If we can get them better, we'll do so. But for now, we're letting the other applications get the cluster and optimize those because they need a bit more work right now. And if we get the opportunity to continue, then we'll like try to do it as better as we can.
Okay, good job. Next up.
Hi, so I'm Samuel. I'm also working on Conquest. I'm the second in the team. Yeah, as said, we just finished our runs. It's a bit sad that the input files are so small. I think we could do much more. We could run on GPU. We are prepared for that. It's not worth it for the size we're currently working on, but we'll do the best of it. It's small, that means it runs only 5 minutes. That means we can do 10 more runs if we want.
Lots and lots.
Yes, we can do a lot of tests, and it will be small gains, but possible, surely.
Small gains add up, though.
Exactly.
Right?
Let's hope we will find the best one. it's hard to say how good we are because we don't know yet. This input is really, it's new, and we'll see if we can monitor the other teams through the power display. Maybe we'll see how they fare, and yeah.
Okay.
Really hyped for the.
That's almost there. I'm thinking about giving another motivational speech, but no. Let's pass the microphone on. Meet someone new.
Thank you.
Hello.
I'm Hannah.
Hi, Hannah.
Working on RACSIAM, so we're doing regional climate
Now,
modeling.
what is that?
Regional climate modeling.
Oh, I'm sorry. I cut you off. Too much caffeine. Yeah. So regional climate modeling. What region?
So we got a new input file, so we haven't actually checked yet. But for the virtual competition, what we got was just over an ocean. They gave us an idealized input, and so then over the run of the simulation, we saw how the atmosphere developed.
That sounds like a starter problem, just a blank ocean.
Oh, but
Is it complex?
well, they're solving like physical equations, so yeah, I would say it's pretty complex. But it's just easier to compare the outputs if you start with like an idealized.
I mean, I
input.
was hoping for something more like you got an ocean, tropical, but then a massive mountain coming out of it, snow on top, going into the jet stream, the winds. You got to figure out what the weather's gonna be there, something like that. I don't know.
I mean, sure, we see clouds develop, we see wind develop, we see rain, snow. So we have a lot going on, but over just a lot of atmosphere
busy
stuff.
problem. Something.
It can be, yes.
Okay. Okay. Good. And you sounds like you're sort of just starting on it.
No,
Oh,
we're
okay.
not. We're just checking out the new input file. So we got a bit of a different version of the model and a new input file. So we did some runs. They went okay, and so we checked what's different and how we can improve.
So you're not satisfied with your final result yet, then?
Not yet, no.
Good. Okay. Okay. We're going to keep pushing for more.
Exactly.
Right. Great. Great. So who's this?
Hi, I'm me, also working on RACSIAM with Hannah. And yeah, as said, we got new input files, also new GT source code. So it differs a bit. And there's a lot of room we can tune and get improvement.
Okay. Good. Now, you're running Grace Hopper, right?
Yes.
That is, this is the first time this has been seen in a cluster competition anywhere in the world. How's it doing?
I mean, up to now we had great experience with it. Everything works. Most of the applications, they run flawlessly. So I would say the hardware itself is great. And we also see high bandwidth between CPUs and GPUs thanks to NVLink. And also the whole system, the IOs and all these stuffs together, they work well.
Okay. There are some problems, though, that are pretty much CPU only, aren't there?
Yes, indeed.
So which ones? What are the CPU only problems? Yeah, pass the mic around.
So for Conquest, the application is normally CPU only. So like the run that we've submitted so far is only working on CPU, and that's also why we were a bit sad to get such a small input, is because we worked really hard, or somewhere at least worked really hard on making it also work on GPU, do some offloading there. And we did manage to do so, but sadly the input is just too small to get real significant like speed up through that.
I mean, that's the thing. You've got CPUs and GPUs working together, very performant. Lots and lots of performance. But the CPUs in here are not that strong.
I mean, there still give some results that we're happy with. But that's still sure that if we had gotten a bigger input, GPU would have helped a lot.
Yeah, I mean they're not helpless.
Yeah, of course.
But they're not like a 64-core AMD top-of-the-line CPU either.
No, but there is still we got.
We have better CPUs than the one you described. We have.
So your CPUs are better than the top of the line AMD or Intel?
We have NVIDIA.
CPUs only. not CPU plus GPU, CPUs only.
Yes, we compared it. So, for example, we had AMD Zen 3 CPUs with 64 cores, and we have 2 sockets per node, and in total we have 4 nodes. And we compare the result, and in terms of CPU-only applications, we still manage about double the performance with Grace, just Grace. And the thing
Double the performance
yes.
of what?
Double the for the applications.
You've optimized it to that. What I'm asking is if your CPUs alone, not with GPUs, just the
Exactly,
CPU,
exactly.
are they more performant than the top-of-the-line x86 CPUs?
It depends on which generation you're talking about. For example, we didn't get a chance to work on the top-line AMD CPUs at the moment. We only worked with the previous CPUs, which is Zen 3 architecture. And with that, it's still better, for example, because first of all, it's older now. So the AMD CPU is still older, and second, Grace has more memory channels, which also helps us
Yeah, it does
do
have
some
more memory
applications.
bandwidth
Exactly.
than some of them. But I
Yes.
think AMD has an advantage on overall CPU memory bandwidth.
I think so, actually.
Yeah.
For the new Zen 4 architecture, this one should be more performant than Grace CPUs.
Let's see.
But this is what we have.
It's good
and we
how
do
you
our
defend
best.
your system. I like that. And that's cool, and it's a good system. I'm just trying to make the point that there's no perfect system. There's no perfect configuration.
Definitely.
There's trade-offs in everything.
Yes.
And you've got great GPUs in here, absolutely. But your CPUs aren't the very best available because they had to slot them in so they fit in with the GPUs. There's trade-offs in this stuff.
There are always trade-offs
There
in
always
HPC.
are. Exactly. What do you think has been the toughest application, the most difficult to optimize? Captain? Take over, Captain. What's been the most difficult?
I mean, I may be a bit biased, but I would say NEKO, so our application.
So yours. You've tackled the toughest, along with you, Leonard.
Yeah, I would say that. Especially, we had to build CPU and GPU versions, and we had a significant speed up with our GPUs. Yeah, we could bring the time like 5 times lower. So yeah, from 500 to 100. So yeah, that's pretty impressive.
It was a good idea to try it both ways. That's cool. That's a good idea.
Actually, yeah. Also, we were forced to do it anyway, so.
Oh, really? Was that a requirement?
Yeah, for the virtual competition now, for the on-site competition, we can choose, but I mean, we would be stupid to choose the CPU version, so.
Yeah, exactly. Exactly.
But yeah, exactly. So I would say NEKO was the toughest one. Pretty demanding.
Are you guys going to win this thing?
We definitely hope so. Like, we'll stay like humble for now and see how the other teams perform, because it's also depending on the hardware that we have, and yeah, we don't all have the same opportunities to optimize, and kind of depends on the application. But we're definitely hoping for the best position we can do. We definitely worked as hard as we could on this.
Yeah. You know what your coach would say? Good friend of mine. He would say, "Yeah, we're going to win.
Guess who will win?
We're going to win. We didn't come here for anything less than that."
We definitely didn't come here to play.
Well, thank you. I hope you're having a good time. You enjoying this? Good. And great to have you. Good luck.
Thank you for the
see what
opportunity. Thank you so much.
Bye-bye.
Bye.